Good morning to all of you. The family nitrogen family. In this, we are going to study the properties of the nitrogen families. Nitrogen family having the elements nitrogen, phosphorus, arsenic, antimony, and bismuth. These are the members of the nitrogen families. We have seen we have studied the electronic configurations of the nitrogen family. In that electronic configurations, we have studied the outermost shell of these elements of the 15 groups having the 5 electron in the outermost shells, that is 2 electron in the ns2 and the 3 electron in the p orbitals, ns2 and np3. Allotropy. Next is property is the allotropy. Nitrogen does not exhibit the allotropy. Phosphorus exhibit the tetrahedral p4 molecule in gases and in the solid form as a reactive allotropes. Arsenic and antimony possesses the allotropy from the reactive tetrahedral form, that is the As4 and Sb4. Bismuth exists in one form, which is metallic layer structures. Oxidation state. Valence electrons ns2 and p3 suggest groups as the +3, +5, -3 oxidation states. Among the positive oxidation state, stability of the +3 oxidation state increases and that of the +5 oxidation state decreases due to the ionization energy. Stability of +3 oxidation state increases and that of the +5 oxidation state decreases from nitrogen to bismuth due to inert pair effect. Nitrogen cannot form compound with the +5 oxidation state, or it has no d orbital in its outermost shells. It cannot be expand its octet and its maximum covalence is restricted to the 4. Thus, nitrogen can't form compound like N5, NCl5, etc. Bismuth exists in +3 oxidation state. Next is the name the oxides of nitrogen. Discuss the preparation and the state of the two oxides. Element of nitrogen family combine with oxygen directly or indirectly to form the large number of different types of oxides. Oxides of nitrogens. Name nitrous oxide, formula N2O, oxidation state of nitrogen +1. Nitric oxide +2. N2O nitrous oxide, NO nitric oxide, N2O4 dinitrogen trioxides +3 oxidation state. Nitrogen dioxides, nitrogen pentoxides having the +5 oxidation state. These oxidation states are more important. MCQ questions asked on this oxidation states. Next is the nitrous oxide N2O preparations. N2O is prepared by the carefully heating ammonium nitrate below 473 kelvins. NH4NO2 gives the N2O to S2O. Properties: N2O gas fairly soluble in the cold waters but partially insoluble in hot waters. N2O has the faint odor when inhaled in the moderate quantity produce the systematic laugh, hence called as laughing gas, that is N2O. In the small dose, N2O is act as the anesthetic. At high temperature, N2O decompose into nitrogen and oxygen structure. Infrared structure of the gases N2O and X-ray diffraction data of the solid and liquid are best interpreted in the linear molecule with two nitrogen atoms bonded to each other. Structure of N2O. Nitric oxides. Preparation N2O, NO is the prepared by action of the dilute nitric acid on the copper furnace. 2Cu plus 8HNO3 gives the 3CuNO3 by 2 4H2O plus 2NO. It is prepared on large scale by Ostwald process using platinum as a catalyst. 4NH3 plus 3O2 gives the 4NO plus 5H2O. Properties NO is the colorless gas and it is neutral in gas character. It is radically soluble in ferrous sulfate, giving rise to the dark brown liquid FeNO-SO4. The reaction is utilized for the brown ring test for NO3 minus, NO2 minus and NO. FeSO4 plus NO gives FeNO-SO4. No radical combines with oxygen and forms a brown gas NO2. 2NO plus O2 gives the 2NO2. Structure. Nitrogen has the 7 and oxygen has the 8 electrons, hence NO is the odd electron molecules. Dinitrogen trioxide structure. N2O3 structure is the resonance hybrid of the following two structures. Structure of N2O3. Structure of nitrogen dioxide. NO2 is odd electrons molecules. Its structure is the resonance hybrid of NO2. Structure of dinitrogen pentoxides. Nitrogen pentoxides. Nitrogen, oxygen, nitrogen. Hydride hydride of element of group 14. Element of nitrogen family forms the hydrides with the general formula AH3. All the covalent in natures. The hydride are NH3, BH3, ASH3, SBH3, BH3 and nitrogen also form N2H4 hydride, NH3, OCl, N2H4, NaCl plus H2O. Structure of AS3 is the barium, nitrogen, phosphorus, arsenic, Sb. Hydrides form the pyramidal structure in the sp3 with the 3 sigma bond with hydrogen and 4 hybrid was the lone pair. Properties of hydrides of nitrogen family elements. Physical steps. Hydrides of the elements of the group 15s are all colorless gases. They have the strong smell and poisonous in nature. Solubility. Solubility of hydrides in waters and the heat of the formation in the hydride decreases from NH3 to SbH3. NH3 is highly soluble in water, but the hydrides are less soluble in water. Solubility is due to the hydrogen bonding between the NH3 and H2O molecules. Bond length and thermal stability. Thermal stability of hydrides decreases gradually from NH3 to BiS3 due to the dissociation. NH3 1773 Kelvin, PS3 673 Kelvin, AHS3 533 Kelvin, SbS3 323 Kelvin, BiS3 298 Kelvin. As the atomic size increases, as the atomic size of the carbon atom increases from nitrogen to bismuth, bond length in the AS3 molecule increases from NS3 to SbS3. Increasing the bond length decreases the bond strength of the bond hydrogen, and hence thermal stability decreases from NS3 to SbS3. Reducing powers. Reducing power of the hydride gradually increases. SbS3 and BIS3 are the strong reducing agent. Basic strength. Hydrides have pyramidal or tetrahedral structure with a lone pair of electrons and has a strong donating capacity. From NS3 to BIS3, electron donating capacity decreases as the size of the atoms increases. It is behaves as a Lewis base. Basic strength has been found in the order NS3, PS3, ASS3, SVS3, and BIS3. NS3 dissociated at 1300 degrees centigrade and PS3 at 50 degrees centigrade. Explain. These are the questions. Increase in the bond length decreases in the strength of HA bond due to which due to which increase in the bond length decreases in the strength of the hydrogen HA bond due to the